Welcome to week 4, Tuesday of Math 25. We're starting with questions on homework in the 10 exercises for metabolism. And the question is on number 3, but we need some numbers from the first 2. So on the whiteboard, we've put all 3 problems. So what numbers do we need from the first 2 problems to do the third one? Because the third one has no number in it except for this 0.3 calories per pound per minute.
I am not sure. When I did the first 2, where is my thing? Hold on.
Okay. Tell me if my volume just changed a lot. I fixed something on my mic. The first one, since you're mentioning it, is about heart rates. We're finding these heart rates. And for the heart rate formulas, then they were just based on age. Age was the only number we needed. So for the first problem, the fact that she's 80 was important. The fact that she is a woman or not physically active in general, or her weight or her height didn't matter.
So I got, for the safe heartbeat maximum for the first one, I got 159.8. For the maximum safe heart rate. So I did the 211 minus 0.64. So 64% times her age, 80. So I got 109.8. So pretty much 160.
Yeah.
For the lower limit of it, for aerobatic exercise, I got 159.8 times 0.5, which equals 79.9, which is pretty much 80.
Yeah, no one talks about heart rates in tenths of a beat per minute, so just round it. Yep.
Yeah. And then upper limit, I did the 159.8 times 0.85, which equaled 136.
Great. That's exactly right. And number 2 is the same, except whenever you had an 80, you'd put a 35. So for the third, what number do we need from here? The hint is in the label, 0.3 calories per pound per minute.
I have no idea. This is the one that I stopped at.
Somebody else can't talk out loud, but could type in chat. I will just, however, go to this. So when we're burning calories with exercise, that's from the health decisions. And here was the formula. We're multiplying 3 things: the weight, the minutes, and the scale factor. So what we need is their weight. For Caroline, she's 120, and for Zachary, he's 150. Everything else in number 1 is a distraction. We don't care about that.
Okay.
Okay, so for Alex, Caroline. Actually, I'm going to label this. No, 20 minutes. I'm
Yeah,
not reading my
20
own
minutes.
problem.
And then times the 0.003, right? Yeah.
Okay, so what are those? We have 120 times 20 times 0.03. So that's 72. And for him, it was 90. So I'll add those together. And get an answer. Questions about any of that?
No, I just realized it's like you're kind of just every like when we go down, you're still using the formulas for the first two, which got me confused. I didn't realize I was supposed to use the like exercise formula to get it. So I stopped at the archery one because for the rest of the problems you need to know that
Yeah,
one.
no, I'm not going to let you forget the old stuff. So.
Yeah.
Okay, here's something a little advanced. If this makes sense, it will help you. And if not, just don't worry about it. We know that when we multiply fractions, we can do some canceling. We can say, on the top and on the bottom, there's even numbers. So we can divide by 2. 2 divided by 2 is 1. We can divide by 2. 4 divided by 2 is 2. And we get 3/14. Does that ring a bell?
Not really.
Not really. Okay, I'm going to keep going anyway, because again, this is just an extra thing. We can do the same thing with words. So here we had pounds and minutes. And just like numbers, if we have the number 3, that's the same as writing 3/1. We can sort of think of these words as like pounds over 1 and minutes over 1. And we can sort of think of the labels as canceling. Pounds are on top and pounds are on bottom. Minutes are on top and minutes are on bottom. And all that's left is calories, which is what we wanted. So if you've seen that before, I'm trying to jog something in your brain. If you haven't, then that probably just confuses you, and ignore it. I will erase it and not confuse you. But
I always took like the longer way around of that. So that's why it's confusing to me, because my old math teacher would do that and I just get confused and then do the longer way, like the other way to do it.
Yeah, so we'll go over that more carefully later, but just sort of as a heads up, maybe jog a memory, then that's a preview of that kind of stuff.
Yeah.
But we will do it slow and careful when it matters. But for now, it's just like an extra thing. Okay, did we want something else from the exercises? Why did we get to help? Because we're doing metabolism. Oh, okay. Let's do 4 and 5 while we're at it, since we're here. Okay. So Caroline's as a percentage of Zachary's. So what do we mean by that? We have two numbers. We have the 72 and the 90. I'm just going to sort of stick them on the board. What am I supposed to do with these two numbers?
Divide them.
Yes, we are dividing. When it says as a percentage of something, the second thing is sort of our baseline. It's like the whole amount. If I said I ate 3 chocolates this morning. I let myself eat 6 chocolates throughout the whole day. How many have I eaten as a percentage of what I let myself eat? Then the thing you say second is like your basis of comparison, your baseline, your whole amount. So when we're dividing, that's the second number. For number 4, we're just going to do 72 divided by 90, because that's the order it puts it in. This one as a percentage of that one. For number 5, we're going to do the other. We're taking 90 and dividing by 72. So let's see what these are. The first one is 0.8. We're still not done, by the way. And the second one is 1.25. Okay. So first of all, why aren't we done yet? We have 2 nice numbers. All the math is correct.
Don't we have to turn them into percentages?
Exactly. So the problem asked for a percent. We'll go right into percent, and we'll get an 80 or a 125. And now we're done. But I also want to ask, does it make sense that this one is less than 100 and this one is more than 100?
A little bit.
Okay, well, let's talk about that more. Caroline's number was 72 and Zachary's is 90. So if his is the basis for comparison, then hers is less than his. So less than 100% makes sense. Half of his would be 45, and she's quite a bit more than that. So her number is bigger than 50%. So this does seem reasonable.
Yeah.
If you flip things around, and now our baseline for comparison is hers, then Zachary's number is bigger. He's more than all of hers. His number is more than 100% of hers.
Yeah.
And so a quarter of 72, well, a quarter of 80 would be 20, and it's about 20 more. So yeah, that seems like a reasonable number. So if the thing that we're comparing is bigger than our baseline, then yes, we should get more than 100. That makes sense.
Perfect.
Okay, I still want someone to ask questions about the typicality or the bell curves, so we don't have to make due dates for those. Someone in chat said pretty much any of them. You want to pick one?
haven't started this one yet.
Well, let's do the first two then. Okay, so in one case we have the mean, and in the other case we have the median. Did you go through the lecture notes or video
Not yet.
previously and see what these are?
I was trying to finish the first one before I try to jump into other ones.
Okay, well, very quickly, mean is the fancy math jargon for add them up and divide by how many, the kind of average most people have been taught all their lives. And median is where you list them in order and then pick the center one. And if there's an even number of items, then there isn't a single center one. So you take the center pair and add those up and divide by how many. So I'm not going to recopy them all, but we can add them up on our calculators. So call out or type in chat when you get your total.
Would it be 282 if you're rounding?
I'm just adding up the 6 numbers, so there's no rounding.
Oh, okay. $294.
That's what I got too. And how many are there? There's 6. So 294 divided by 6 is 49. So the median isn't a formula, it's a process. We're going to list them in order. So what's the smallest one in our list?
5.
5, then 11, let's see, 15, 33, 95, and 135. Then we find the middle ones. So 15 and 33 are in the middle.
And then you said you add them together and divide by 2?
Yes, so 15 plus 33, and then divide by 2. It's 31.5. This isn't a word problem. I don't know if these are grams or heart rates or whatever, so I'm not going to round it because I don't have any real life context for what's sensible rounding. So just as sort of a teaser for going to see this eventually, notice that with the median, it doesn't matter what the biggest and smallest numbers are. If this was 9,135, it would be exactly the same.
Okay.
So the median is useful for things like incomes at a job where the CEO doesn't really represent what's happening, or perhaps housing prices in a neighborhood where one house has had all sorts of remodeling and the others haven't. That if you're looking for what's typical, and either the very biggest or very smallest are going to mess up your mean, then the median is a way to say, let's try and see what's typical about the middle group, not the extremes. Okay. The bell curve ones, that's just basically reading a chart and doing some stuff. And if that winds up being due on Monday, that's okay.
Okay.
So okay. Questions about mean and median?
Mm-mm.
Okay, our person writing in chat got it correct, so I think we're good. So, so health decisions we're pretty done with. If you want me to look at more problems from the overall test, we can. That also might be a good thing to do on Friday, because then we'll be fresh in your mind for the weekend if that's a good time to work on this. Personal finance decisions, we've done typicality and bell curves, and we've done a little bit of mortgages, but not all of it. So let's go back and review mortgages and finish it up. So we started by talking about how much you want to pay per month. And this is a little odd because you need to know your pre-tax income and your after-tax income. One of them you multiply by 0.35, the other you multiply by 0.25, and then pick something in between those. And that's a guideline. It depends on where you're living. Certain places in the country have higher or lower housing costs for your household. But in general, that's what people recommend. Let's imagine that we can spend a certain amount per month. Then we had this bizarre table, the amortization table. And that says if I wanted a loan from the bank for only $1,000, how much would I pay each month so that I would pay off the loan in the right amount of time? And we talked about how this is just a sort of simple group of examples. In real life, there's a lot more rates than 4 whole numbers. What if you had 3.72 as your rate or something? And there's a lot more year options. You could have a 12-year mortgage because your kid is going off to college in 12 years and you want to pay off the house before you have to deal with college payments or something. But for our problems, we're just using these numbers, and just know that in real life, there's more. And we can use the table forward and backwards. So first, let's use it forward. And I'm going to avoid repeating myself from last time. Let's not do exactly the same problems. So I'm just making up a problem. Let's do 15 years. Let's do 5%. So that gives us $7.91. if you wanted a $1,000 loan, because notice at the top it says per thousand of loan, then you would have to pay $7.91 every month. Now that would be kind of silly because you can't buy a house for $1,000. The house that we're looking at in this problem has 190,000. So that means we're going to take 190 and multiply it by that $7.91.
Only the 190, not 190,000.
They could have made this table using tiny decimals and you'd multiply by the actual loan amount. And then it would say at the top per dollar of loan. But that's not what they chose to do. Whoever designed this table, and we just have to follow their invention, said, let's count thousands of loan. So how many thousands did we have? We had 190,000. If you would have done it differently, then I might agree with you, but too bad we have to do it the way it is. Now we're dealing with money, which makes rounding easy, right? Dollars and cents. Questions about that example?
So because they're doing 1,000 alone for the monthly payment, you're always going to pick the just numbers before the 1,000, like just those numbers.
Yep, just kind of peel off the 3 zeros.
Okay.
What would happen if we changed it? If this was not 190,000 even, but 190,800? Then instead of thinking of it as peeling off the 3 digits, think of it as 3 scoots to the right. So we would get 190.8. The comma becomes the decimal point. But that's not what this problem was.
Okay.
Okay, now that was not too bad, but unfortunately it's not realistic. No one will ever say, congratulations, you just bought a house, go find out your own monthly payment, right? They tell you what the monthly payment is. So
Yeah.
what's useful is to do this backwards. So just like we had yield percents, you could do them forward with multiply or backwards with division, then the same thing is happening. So now we're going to say, what monthly payment should we use? Just pick something.
Of just any of the numbers on the side.
Not a number on the side, just a monthly payment amount. So, you know, something that's more than 500 and less than 3,000 would be a
Let's do 2,500.
2,500. Okay, so expensive housing. Okay, and currently mortgage rates are 6%. I'm just picking something. And how many years do we want our loan to be?
What's a reasonable thing for that?
One of these 5, 10, 15, 20, 25, or 30.
Let's do 20.
20. Okay. So like before, we find the 20-year 6% number from the table, and we get $7.16. So we're going to do something with the 2,500 and the $7.16. And remember that every time we pay the bank $7.16, then we get $1,000 of loan. So imagine that you walk into the bank with 2,500 in a bag, and you're very methodical, and you go to the teller and you say, here's $7.16. You pull it out of your bag. And they say, great, you've now qualified for $1,000 of loan. And then you give them another $7.16. And the bank teller says, great, you're now up to 2,000 of loan. And you give them a third $7.16. And they say, now you have $3,000 of loan. And you keep doing this until you run out of money in your bag. So do you see how that's division? How many times does this fit into the big number?
Yes.
So we take our 2,500, we divide it by that $7.16 from the table. And whatever that is, I get about 349.
Yeah, that's what I got too.
And that 349 is how many thousands of loans you qualified for. How many times you could give them 716 before you ran out of money in your bag. So what we actually write is 349,000 like that. So just like before, those other 3 zeros are just sort of hanging out because we're counting in thousands, we're not counting in ones. I'm going to flip back and forth between these two slides. Here, we peeled off the loans thousands, multiplied it by the table number, and got a monthly payment. That was forwards. Backwards, we started with the monthly payment, divided by the table amount, and got something to stick in front of the thousands. So that should look nice and symmetrical. One is forwards and one is backwards. Questions on any of that?
No.
Okay, text chat is quiet. Holler if I'm needing to do more. Okay, I am not going to repeat this thing about how real life is more complicated. There's down payments, there's mortgage fees, there's monthly payments up front. Look at the video from last time, read through this here. And this one, we're going to just do a new example problem all the way through. So at home, if after you watch the video from Monday's class, try 22 and 23, see if you can finish up. But I'm not going to repeat myself, that would be a waste of time. We'll just make a new family with new numbers and go all the way through beginning to end momentarily. Also, not during class time, there's a little essay about bank safety. Why do banks give mortgage loans? Why can't banks invest all their savings in the stock market? What happened with the Great Depression? What's the velocity of money? What happened with the 2007 recession? Things like that. So read that on your own. It's interesting. You can be a well-educated person, but I'm not going to do that during class.
Okay.
Instead, let's just look at these random exercises. And again, remember your tests are just bunches of these stuck together. So here's a new family and everything for them. So we're doing a little more than we did on the last class because again, we have more parts. There are the things that I just told you I am skipping over that we are going to do here. But we're starting from the beginning. Mariposa can afford a monthly mortgage payment of $950. She wants a 25-year loan. The interest rate is 6%. How large a home is affordable for her? So this is exactly the same as what we just did. We're doing the table backwards. We're starting with a payment and finding a loan size. So for her, 6%, 25. So this is the number we're using from the table. $6.44. And what do I do with it?
Divide.
Divide. So I take her 950. So problem A. Divide by that 644. And whoops, I needed a decimal point. And we get about 146. So a $146,000 loan. Okay with part A?
Yes.
Okay. Eventually things get complicated. We're going to skip some of those complications with brokerage fees and so on. That's too much to put on a test. I don't want to waste your precious test time. But the down payment is a big deal. So let's do that. The down payment is 20%. So we're asking, what is 20% of 146,000? We did a bunch on these percent sentences last class. There were two ways to solve them. You could translate or you could make a proportion. So I'll do both. The translate method says that what is an of becomes what becomes your letter, is becomes equals, of becomes multiply. Numbers stay the same. So 146,000 is just 146,000. And the percents we're going to change into decimals because it's easier to put them in the calculator reliably that way. So we're going left out of percent, 20% becomes 0.2. So 29,200. The proportion method says that I make the skeleton of a proportion, fraction bar equals fraction bar. I take the percent and I set it up not as a ripple up decimal, but as a fraction. So 20% is 20 over 100. The bottom of this side is always 100, and the top is whatever the percent number was. On the other side, there's always something that comes after the word of. In this case, it's the 146,000. And then there's something we haven't used yet. And that goes on the top. And in this case, it's the what. So you set it up like a proportion using that process, percent on one side as a fraction, percent over 100. And then on the other side, the thing that comes after of on the bottom. Then we can solve this by cross multiplying. There's a shortcut that we used a bunch yesterday, but I'm going to not use the shortcut today just for variety's sake. Make those look more like dots. Okay. So 20 times. I have y times 100 is something else. To get y by itself, I should do divided by 100. And if I do it on one side, I have to do it on the other to be fair. And we get the same answer, unsurprising. Okay, don't have to know both of these, but pick one method or the other and learn it well. Questions on whichever one you like better, or is one of them okay?
I remember doing the translate method in my other class. So in my notes back home in Oregon, I have like what is equals and like what of like translates to. And so I think I was doing the translate method more than the proportion method in my other class, in the Math 20 class.
If you need review on that, then just like the link from yesterday's email said, it's in the percent sentences part of justice. Justice is doing the same thing to both sides of the equation, like a balanced scale, and percent sentences there. Okay, so 29,200 is our down payment. Okay, part C. The loan has a 3% fee. What is the fee amount? So the trick here is that we're not asking what's 3% of 146,000. Why not? I'll give you a hint because I've lied to you. This word here shouldn't actually be loan. How should we label part A? .
Would it be the interest rate?
No, a rate would be a percent.
A rate would be a percent.
So this was how large a home she could afford. I'm just going to use the word home. But the subtlety is that the loan, you have to take the home size and subtract away the down payment. She doesn't need a loan on what she's paid. The loan is just on the rest of it. So the loan is going to be, well, we take what we need to pay for the house and then subtract away that down payment. So I'm getting 116,800. I did my typing on the calculator right. So now we're asked, what is 3% of that loan?
$35,040.
Yes, 3,504. It's 0.03 times it.
Okay, yeah, I did the 0.3, so that would have been 30%.
Yeah. Did you get the same in chat? Let me write it out. I'm waiting. Okay. Whatever that was, 116,800. That would have become the 0.03 because of the rip flop, and the rest you can figure out. I'll write it later, but we're running low on time. Okay, now D and E. How much in monthly payments will she pay over 25 years? Well, we're not ready to do that yet. She said she could afford monthly payments of $950, but that's not what her monthly payment will actually be. Her monthly payment will be less because she's made a big down payment. She doesn't have a loan that's this big. She has a loan that's smaller. So we need to sort of start over again. So I'm going to grab the chart. That number. So for D, here's our loan amount. And we still had 6% in 25 years. So now we go forwards. Remember the forwards, backwards. We're going to take that amount This is why I warned you about that. You can think of it as taking 3 scoots there to turn counting by ones into counting by thousands. This is not riplop. Don't think we're doing anything about percents right now. We're not. We're just saying that this table is based on $1,000 of loan, so we need to count by thousands. Change your comma into a period. whatever makes sense to you in your mind.
Okay.
So it's the 116.8, and then we're going to multiply that by the 644. And get $750.26. And we talked a lot yesterday, but I don't want to repeat myself too much. The problems are specifically designed that she's under budget. She budgeted for 950. Her monthly payment is only 750. And we're assuming that's because she doesn't have 29,000 cash lying around that she has to pay back some relative or pay back her kid's college fund or something to make that down payment happen. So it's okay that her mortgage amount is under budget because she needs that to fill in the gap for the down payment. Okay, lastly, oh, and how much? I put a box around the wrong thing. So that's her monthly payment. How much will she pay total over the 25 years? So she's going to write that amount in her checkbook or bank auto pay, whatever she does. She multiplies it by something to make it bigger. How many checks does she write over all 25 years?
Was it wrong to do like 750.26 times 12 and then times a 12 times 25, or is that completely wrong?
Oh, that is perfect.
Okay.
Every year she writes 12 checks, and then she does that 25 times.
So then it would be 225,078.
Correct. Then lastly, that's how much comes out of her checking account. Anything that's not, oops, 116, anything that's not the size of the loan has to be interest because there's no other category, okay? It's either the loan or the interest. So from that, we subtract the loan size, the 116,800, and get 108,278. Okay, does this slide make sense?
Yeah.
So I keep saying again and again, don't do your work all by yourself. There's nothing we've done in this mortgage problem that's hard. We've done a little dividing, we've done some subtraction, we've done a translate method or a proportion method, your choice, which is again not that bad. We've done some more multiplying, we've done some subtraction, right? These are all doable steps, but there's so many steps. The chance that you can do all of this, especially if you're up late at night and your brain is tired and you're trying to get your homework done, is, and do it accurately, you're just asking for trouble trying to be accurate with so many steps. So if you make mistakes, don't feel bad. Everyone does. You saw me write the wrong numbers and catch myself. And if you have somebody, whether a classmate, family, friend, whatever, to work with you, then it saves so much hassle, because then they can be looking over your shoulder and say, oh, no, you forgot this step, or that number should be a 6, not a 1, or whatever. So if you have to do it by yourself, you have my sympathy, but hopefully you have somebody else that can be working with you, because there are just too many steps. It's too easy to make a careless mistake, hit the wrong button on the calculator, forget a small step, something like that. But once you practice, it's sort of like riding a bike. Once you get used to it, then it's not that bad. Again, we just did the random problems, not the 10 exercises, but the random ones. And every time we reload it, then they change. And there's always answers. So you can keep practicing as much as you want. Anything else before we're done for the day? No, I'm going to turn off the recording just in case maybe you do have questions